Bonjour, my name is Ali. I work at Google, where I lead the AI cybersecurity research effort for both Google and DeepMind. And today, I would like to talk with you about the lesson learned from developing secure AI workflow at Google. This video is a pre-recording of the talk I'm about to give at RSA 2024 on the subject. Before we get started, if you would like to have the slide of this talk, they are available as a URL you can see on screen, and there should be a link on the description of the video as well. With this out of the way, let's get started. In the last year or so, we have seen an explosion of AI-powered application due to the rise of large language model, which offers this very intuitive, natural language way to interact with AI and have incredible generative capability from text to image to code to structured data. And those systems, like any system, obviously have vulnerability and are facing numerous risks that needs to be addressed. What makes those systems different to secure than they do face classical risk, such as vulnerability in their infrastructure or maybe denial of services, but they also have a specific unique risk, which are due to having a model and a model who can generate content. Some of those might be model backdooring or having the model having a prompt injection. And so to help the team internally at Google first, we decided to develop this framework about a year and a half ago called SAIF, which is a secure AI framework. And then we've been gradually making it public in the hope to share what we learn and learn from others what are the best practices around securing the AI system so we can all together as a community have the best set of control and understanding on how to go about it. So what I would like to do today essentially is give you a fast-paced tour of how we think about AI application in general, what is our mental model, as well as what are the risks we think those systems are subject to and what kind of control you can put in place. All of those obviously with a lot of concrete example to make it very practical. So hopefully that will help you form your own mental model and understand how you can go about securing your own AI system. It's going to be fairly fast. So if you have any question or any ideas on how to, or which control we might have missed, or idea on how to improve it, please reach out via social media. We'll be happy to talk about this anytime. Obviously, the discussion in this talk have nothing to do with a specific product or a specific model. We are looking into how to do it in a holistic manner. So hopefully that would work for any kind of system, at least part of it. And so it could be applicable to your own systems. We think about an AI system in four main components, which are the data component, which is in charge of collecting and processing data, the infrastructure component, which is in charge of training the model, serving the model, and so forth, the model itself and its plugin, of course, and last but not least, the application, which is the user-facing part of the model. And that can be a UI, like Gemini, or it might be an API like Vertex or AI Studio or anything like this. Doesn't matter, but this is the part which is exposed to the world. And last but not least, we always have this fifth component in security, which is governance and insurance, which is how to make sure the system as a whole is both secure and compliant. So we're going to explore each of those in turn. If you want to have a more concrete view of how that looks like, this is the diagram we're going to use for this talk, which have these four components and sub boxes that we're going to discuss one at a time. So the way we're going to go about it, essentially, is we're going to first describe what the components are doing, so we get a shared understanding of what those boxes mean. Then we're going to talk about the risk which are faced by those components, whether they are traditional risk or AI-specific risk, and I will try to make sure I highlight which one is which. And of course, we're going to talk about control, which is how we try to go about mitigating those risks. So let's start with our first component, which is data. So the goal of the data component is to securely collect, store, and manage data, which is used both during model training, but also doing fine-tuning and retrieval, which might be at runtime. People call it publicly RAG, which is Retrieval Augmented Generation. And so we clump everything which is around data manipulation storage as one component called data in our mental model. And so this data component have essentially two parts. The data sources, which is where do you get your data and how you organize it, might be a data lake. If you have consumers, you might have multiple separated data sources per client and making sure, of course, they are separated. And you might get them from internal data or external data, but from the perspective of the system, those are external sources. And then we have this very, very important second component, which is the data filtering and processing component, which is in charge to making sure that the data doesn't go unfiltered into the infrastructure. The last thing to mention before we go further is at the bottom right corner, you'll see a navigator which helps you to know where we are at. So it's going to be which component we are, and then it'll have whether we are talking about risk or a control in case you happen to be lost into where we are in the presentation. All right, so the first risk we should discuss, which is a very, very big risk, is data and model poisoning. And this is particularly sensitive if you end up processing data which is either from consumer or from external sources such as external data set or scraping part of the web or collecting data in the wild. A very concrete example of that is many products, including Google's one, have reporting user flow to help understand if everything is going well. So for example, on the top left, we have the Gmail reporting UI where you can report whether it's a spam, it's phishing, it's illegal content, and those trigger a review on our side. Similarly, Gemini has a thumbs up, thumbs down to help understand if the generation of the answer was okay or not. The problem with those flow is because they are exposed to end user, you cannot fully trust them. Here is a concrete example of that. This is a production graph taken from the Gmail reporting data. And as you can see, we saw those red spike, which is essentially a report that some of the things were not actually spam. And those are not real user complaining. Those are attacker trying to poison the training data and trying to basically force us or trick us into believing that their spam is not spam. And so this is an example where you have to filter to avoid the flags reported by your user to be used to skew your data. Of course, most of the flags are quite helpful and they are an integral part of the system, but you have to treat them as unsecure input as there's a risk of them being weaponized. And so the way you go about that is by making sure that every time you feed something to a model, no matter where the data is coming from, you have to make sure you sanitize it and you look at it. And the way you could do that is, depending on the type of data, you have to use supervised classifier to look for toxicity, hate content, non-safe for work content if that's not something you want in your data, or anomaly detection in the case of user flags and other data which is non-textual or non-images and media. So very, very important, and probably one of the most important control we have is going to be in our top 5 at the end. Beyond this one, we also have 2 other controls we need to enforce at the data component level. The first one is we want to have user management control, which means you want to make sure that everything is actually authenticated and gated behind access control. And similarly, you want to have training data management, which is making sure that one data sources is not crossover with others, and you know what goes into your model. You probably don't want, let's say, having a sales chatbot using internal sales data and so forth, because that might lead the chatbot to reveal information you don't want. So traceability and proper accounting of the data is also very important. And the one thing here I cannot stress enough how important it is preventing unauthorized access using very, very strict access control. What I mean by strict means you should not have any public access to your raw data, and that should be enforced throughout every data sources you have. That will be, again, also one of our top 5 control to implement. Moving on to infrastructure, our second component. This component is used to securely train, fine-tune, and serve AI model. So this is a part where you connect with the GPU and the infrastructure. And we have in that component 4 boxes. The first one is, of course, the model. and the framework code. All models are made of code, and so we have to consider when doing the infrastructure, where is the code for the model and the framework used and how it is secured. Then we have to have all this loop around training, tuning, and evaluating models, which is the one which interact with your GPU, TPU, and so forth. And then we have, when the model is trained, where is it stored and where is the data related to the model stored as well. So that's the third part. And of course, we have the serving part, which takes those model and data and put them into a queryable interface. And so those four components have quite a bit of risk and control you need to put in place. And so let's go explore a few concrete ones first. So the first thing you should be paying attention to, and people sometimes forget that, but model are code, is the model source can be tampered. And it happens more than often than people might realize. For example, most of the models are made using Python code and weights. And so when you serialize them, there is the ability for the attacker after the fact to modify those files and be able to include additional code which is malicious. And this is not a abstract risk. So for example, Hugging Face, which is one of the largest model repository available online today, had quite a few model files which have been backdoored by that method to allow to have a reverse share, to write files, to do a ping, and so forth, due to the fact that those serialization are by itself insecure. And this is not a new risk. And of course, this is not unique to Hugging Face. Any kind of model serialized file can be backdoored. And this is a classical risk. There is the flip side of that, which is you can also have an attacker, whether it is after the fact or before training, who can backdoor the architecture of the model, meaning the code which defines how the model is organized in layers can be modified by adding extra layers, whether they are doing during at inference time, as it is displayed on the screen, or as an additional layer which execute Python code to do a reverse share or something like that. There is a risk that your architecture might be backdoor. And this is quite hard to spot because models tend to have hundreds of layers now. And while they are looking all the same, some of them are quite complex to unpack. For example, if you think about those large language models, they use a layer called attention. And this attention layer is quite complex due to the fact that there is multiple interaction and a lot of optimization done. And it's not unreasonable to expect that someone can sneak in a backdoor there, and it will be really, really hard even for people who understand quite well machine learning to spot it. As I mentioned, we can think of the backdoor as an architecture tweaking and doing something at inference time, but you can also have pure Python because most of the framework, whether it's Keras, JAX, TensorFlow, or PyTorch, they're all Python. So you can literally get one of the layers to be essentially a Python lambda, which will execute random Python code at loading time. Here, for example, it is creating a backdoor. In a similar vein, you also want to ensure that these backdoors do not happen at the training data stage, where if you put unauthorized data into your model during training, but also during fine-tuning, you might end up with the wrong thing. A classical example in the sense has been very, very public was this fine-tuned model done by Mitria, which shows that you can very, very easily backdoor, I believe it was a Llama 2 architecture with a little bit of data to make it actually on specific query reporting misinformation while behaving perfectly normally otherwise. And those are extremely hard to spot as well because unless you know which type of query it has been trained to actually misbehave, it's almost impossible to detect. And so the best way to address those things is to have an approach where we are looking at secure by default. And here, the best control we have for ensuring the integrity of a model is to sign it with the recently released verifiable model provenance, which essentially use cryptography to sign and assess that the model itself, the weights, and the serialized file, everything is fine and has been signed by the people who released it. It allows you internally, if you want to sign your own model, and also externally when you check a model which is public, to assess that the model haven't been tampered with. And that's where actually crypto, which is quite a classic technique, actually shine to help us ensure the model integrity against those AI-specific risks. Another AI-specific risk is model exfiltration. And so here, there is two ways that might happen. The first one is kind of classic, where you have API tokens which are leaked, and then people get unthreatened access to the model, and you have to reset the token. This is not something new. A lot of API tokens have leaked in the past. A more specific and AI unique risk is, well, you can do it by reconstructing the weights. So a set of various attacks which actually either look at the gradient or look at the output of the model to figure out a little bit about how the model is, and with enough queries, you can actually recover quite a bit of the model. And so those are going to have to be addressed with traditional control. So for example, rate limiting. For our vision classifier, we do not report the exact value of the model, which is the output of the softmax for those who are expert in AI. But instead, we report a bucket value to make it harder for people to reverse or exfiltrate our models. Those can be, once again, addressed with model and data control. And you need to ensure that the access to the data and the API as well is properly stored and treated as secret. Make sure that your API keys are not put into a GitHub or put into any kind of publicly available sources where an attacker can find them, which is quite a classical risk. The risk we have in that component are unauthorized training data, model poisoning, we talk about model exfiltration, but also model deployment tampering, where an insider might be able to, after the model is trained, go back and modify it. Hopefully crypto will prevent that, but without signing a model, that's a risk. And of course, tampering the model sources even before it's been trained. And to address those, we have adding privacy enhancing technology to make sure that the training data do not contain PII or do not contain data that you don't want to see leaking. Making sure you do adversarial testing and training and testing to make sure that actually your model is being tested continuously against backdoors. Making sure that we have access control, ensuring that we have good control by default and everything is by default gated behind access will be one of those. And finally, more adversarial training and testing, which means we still want to be able to check and evaluate everything and making sure that you do exercises to pinpoint vulnerability into your infrastructure. Looking at the models themselves when they're in production, the goal here is to make sure that we can safely process user input and model output. And so in terms of the model itself, it's mostly covered by infrastructure. So two things which we need to understand and protect quite carefully is model input, which is what the user is supplying. But we also need to pay attention to what is the model is outputting, because those models are able to output code, output data, and therefore, depending on how they interact with your environment, that can be used to be dangerous, very much like web security, where web pages contain JavaScript, which makes them executable in a way. And it is a problem and has been like the number one problem in terms of, I believe, CVE. XS has been the number one for like year and 10 years. This is about the same problem. And so in that vein, so one risk to pay attention to is having the model outputting something which is unsafe. And this is a classical risk in the sense of we have seen web pages having insecure JavaScript, and you need to properly sanitize it. And so if you forget to sanitize the output of your model, you end up with a model which is able to essentially include something into the password file because it has access to the whole system when it's not properly sandboxed and sanitized and so forth. So it's quite a risk, and be careful that when the model output code, if by some reason the attacker is able to inject something into the prompt who tamper with the output, you should not trust the output of the model. Very, very much like a type 2 XSS, if you would. And one of the things you can do, once again, is to do adversarial testing and training on your input and output to make sure that the model is behaving and your defense system are behaving the right way. And here, I think one of the most bang for the bucks you can get is organizing red team exercises to get people get creative into how they can test if the model is doing what it's supposed to do. It might be done by the security team, but you could also invite other users from your organization to play with the model and see what they can find. That is quite unique to that specific type of application because you interact with it with natural languages. So a lot of people who traditionally could not participate to those exercises due to the technical skill banner can actually help out. So might be a fun exercise to do. We at Google had quite a few of those exercises where a lot of people did participate and found quite a bit of interesting behavior on some of our models. The flip side of that is, of course, that input time prompt injection, which is the ability to derail the model instruction. Here, I would like to highlight one AI-specific risk. It's not new. Adversarial input has been around for about 10 years now. But, for example, if you were to use the system to pre-process resume before deciding who should be screened further by your recruiter, then there is a risk that the model can perceive a invisible image like Daniel Feldman shows on Twitter. And then what's going to happen is the instructions are hidden into the image. The model do see those almost white on white text and is able to read it, understand it, and then use it in its reasoning, and you have something like hire him. And so be very careful that the model are very, very sensitive to input in a very different way than human would do. And this mismatch has been quite a bit of a staple of adversarial attack against model for quite a long time now. In terms of control, well, it's exactly like a web page. If you have the web security model in your head, then that's about the same. You want to have input validation and sanitization. You want to have output validation and sanitization. So both input and output, very much like a web page. And then you would do that by having input and output security classifier. And of course, code sanitizer to make sure that you scrub out any kind of potentially harmful content. And when you interact with plugin, be very careful. We'll talk about that in a minute. And some of the risk we have to consider is also that the model might be able to, or might reveal sensitive data. And here it's a little bit more complicated because that type of control has to be at a different part, which is you probably want to use privacy enhancing technology to make sure that the data which you fed into your model before training has been PII free, unless you want the PII because you want to answer a specific question from a customer. Always ask yourself, should it have this type of PII? And if not, does those PII in my data set? And that is the surest way to avoid the model being tricked into disclosing sensitive data is to not have it in the first place in the training data. One of the ways you could do that is adding differential privacy into your training processes. The downside of that is, as you can see on the slide, this is from a recent paper, is that the accuracy is going to suffer a little bit. So you are taking a trade-off between privacy and accuracy. There are other approaches like filtering by hand and having specific filters, which might help as well. Will really depend on your use case. And so if we look at the overall set of risks we have for model, we have the prompt injection we discussed, sensitive data disclosure, but also the ability for the attacker to infer sensitive data, a little bit like a side channel or a blind SQL injection might be another apt analogy here. The model might output something which is dangerous, and then if you process it further down the line with a code interpreter or directly with a system, you might end up backdooring your own system. And then model evasion, meaning that despite your model being aligned and your model being able to be taught to avoid doing something, there might be ways to contrive the model to perform something which is unexpected. And so in terms of control, the first one, as I said, which is very important in our top 5 is making sure you validate and sanitize the input, make sure you adversarially test your model, and of course, making sure you validate and sanitize also the output, so input and output, as you would do with a web application. Last but not least, in terms of functional component, we have application. And here the goal is to securely integrate model into complex application. That component is essentially 2 parts. So the first one is the application itself, which is what's facing the users, and then a set of plugins that can be that might be written by yourself or might be written by third party and are integrated into the application and that the model can query. For example, retrieving something from the internet, or in the case of Gemini for us, going to talk to YouTube, going to talk to Gmail, going to talk to Drive and so forth. One of the risks is that the model might have a plugin which might be under your control or might not be under your control, and this plugin might have a vulnerability itself. And that would lead you to another risk, which is the model might perform a unauthorized action. For example, deleting a document or sending an email you don't want to, and so forth. So those are quite dangerous when you have integration with user data or having access to systems which are quite powerful in terms of cost or action that might be damaging to our users. An example of that is, and it's a classical risk, is that if you don't sanitize the output of your plugin, you might lead to exfiltration of data you haven't planned because the plugin will happily do what the model wants. And if the model actually is asking for something which is not properly gated and the plugin have too much capabilities, not following the least privilege possible, then you might end up disclosing information. To mitigate that, you have to have application access management, meaning making sure that the right user have access to the application and you maintain the traceability of who is making the request to make sure you propagate access control. And you also make sure that when the plugin is making a query, it is aware of which user is making the query and you avoid any kind of confusion. And we can further out do another layer of security, which is showing a consent and control to the user when we're about to perform an action, which might be dangerous for the user, such as deleting something and so forth. Another very classical risk is denial of services. That might sound completely stupid, but denial of services do happen to any system which is not properly protected against them. And as we said, this is a user-facing part of your system. So obviously someone eventually will try to DDoS it. And that is a very classical risk which happened a while back to ChatGPT, but will happen to any kind of other user-facing system, in particular because those models are very, very GPU hungry, and so every request is quite costly. So you want to make sure you put defenses in place there, such as rate limiting, of course. So essentially, there is nothing new here to do except making sure that what you have been using for your front end and been using traditionally to do DDoS mitigation is applied. Another risk is the fact that your application is built on a ton of libraries and a ton of systems, and some of them might have vulnerability, which in turn will compromise the whole system. And that leads again to the risk of unauthorized model action, and those are basically one follows the other. We have denial of services, and we have model reverse engineering, which is a different form of model exfiltration, where you try to reverse engineer not only the model weight itself, but how the model is working and what is behind it, and maybe what the API key it's using for its plugging and so forth. And so to address all of this, we propose again to do some adversarial testing and then having application access control. Use user consent and control when the model is about, or the application itself is about to do something which is quite dangerous and having some mutable state, for example. Making sure that the plugin are aware of who is making the request and making sure that similarly they do enforce access control. And then making sure that the plugin have a permission system, and by default you do not enable plugin without the user knowing what we're going to use, unless of course it's like a chatbot and then you have to do the permission yourself, but make sure that model don't have unbounded access to plugin without some sort of permission and control. The last part of this talk is about governance and insurance. And here, what we really want is making sure that any AI system operates safely and in a compliant manner in the entire life cycle. And so it's not about one component, it's about making sure all the components have the same control and work well together. So concretely, if we go back to our question of insecure integrated component, we could have, well, making sure it's not insecure and there is no insecure code. But the reality is that we fell into the larger realms of you should not have insecure code anywhere into the stack because that creates an exploitability risk. And so this is a very classical risk, but it affects AI systems the same way. So for example, a few months back, there was a bug into MLflow, which is a very popular ML workflow system, which allowed to have remote access for stealing model and poisoning. And this is a very classical vulnerability in that specific case. So what you really want to do is making sure that you apply the same code review and code update and code sandboxing practices throughout your entire system than you would do for a normal application, which are considered very sensitive. So the one here we do recommend that Google use and is kind of the cornerstone of our security is to make sure you do code review. You should not ideally have any code in production which has not been reviewed by at least another person, because that will help reduce security bugs and mitigate insider risk as well, because that would force an attacker to have a person to write the bug or the backdoor and another person to actually agree to have the backdoor being released in prod. So practicing code review is one of the greatest way to mitigate security risk. We also suggest, as we did, is to expand our bug bounty last year to cover our AI systems. It's a little bit tricky because there are things which are hard to put on the bug bounty, for example, prompt injection. However, we think we have landed on quite a few interesting set of criteria. If you want to use those as inspiration, there is a link at the bottom of the slide, which lead you to our blog post about it, and you'll see we have all our criteria being listed. And so far, we have been receiving a dozen bugs, which have been fairly interesting and useful to help secure our infrastructure. So a big thanks to our bug hunters. So the takeaway from that talk. Well, the first one is AI systems do have this unique set of issue, which is they are facing classical threat, but they're also facing AI-specific threat, which must be addressed. We need, as a community, to make sure that when we secure the system, we implement control across the entire stack, not only at the model level or application level, but also as early as when the data enters the system. And implementing the classical control is going to be very important and probably the first step that everyone should do, and you will get a lot of bang for the buck by doing the simple thing. And we're going to go to our top 5 in a minute. But we also need to implement some innovative and novel defenses which are there to mitigate some of the AI-specific threat. And I would love to tell you that this is a solved problem, but actually defending against some of this type of attack, such as prompt injection, is still an active area of research because no one has found yet the right set of technique to actually mitigate them enough that they are considered solved. The way I would apply this talk would be today, try to probably go back to the slide and think through what are the risk and control you have for your own system to better understand what is at risk. And when that has matured, in the next 6 months, you start by adding control one after the other, where they are the most helpful to improve your security posture. I know it's a little bit overwhelming how many control and how many risks we have to face. So here's my top 5 of control you might want to consider for your application. The first one is filtering the input of your application system, very much like any kind of web application, which include having safety filter and transcoding input file. If your system is supposed to process video, images, and so forth, make sure that before you pass them to the model, you do transcode them to avoid any further risk. This is very, very similar to how you would do it for a web application. The second one is don't assume that because you have a filter input, you are safe, because remember, the model can in itself generate code. So I would also take a moment to make sure that I have output filters who do web sanitization, meaning make sure that if you output web code, it's not, can be used to exfiltrate content out of your application. There has been quite a bit of bugs on SVG and so forth, so be very careful. Code sanitization, making sure that whatever code the model is outputting is sanitized and sandboxed. And of course, output safety filter, because you never know what the attacker might be able to get the model to generate. So don't trust your output. The third one is try to sandbox and enforce least privilege throughout your entire AI application. So there is no reason that an AI application have access to file edit on the configuration file of your web server. There is no reason that your model should be able to, or the Python code processing your model should have access to the underlying system or the network around it. Make sure you firewall it and so forth. So I think making sure you isolate as much as you can. So classical techniques essentially will be going a long way to make sure that you don't get your entire infrastructure compromised if there is a vulnerability somewhere in your AI application. Enforcing access control is, I think, is a must. Making sure that you should not have any model code or data which is available to the public, of course, but also to a wide range of groups will be going a long way into ensuring reducing insider risk and also reducing the risk of leak and exposure. And last but not least, be careful that the security of a model starts by making sure that what goes into the model is actually what you want. And so you have to be very careful of sanitizing the data you put into it and making sure you track very carefully where this data is coming from to make sure this is exactly what you want for compliance and for security reasons. And I think with those 5 things, you will have been way on the way to have a more secure AI workflow. And those will be, I think, quite the one I would start with if you haven't them already. As a final note, thank you so much for listening in. As I mentioned, the slides are available in the link you can see, and the link is in the description as well. And if you have any kind of question, please don't hesitate to reach out on social media. Always happy to have a chat. And hopefully together we can find ways to make our AI application safe and create a world where AI is safe for everyone. Thank you so much for listening in.